Okay, so this is question 17 of the test for review. So the first thing that we want to look at is it says sample proportion. So we're talking about proportions and we'll be in proportion stats, all that. And so first we're going to identify our proportions, which is our successes divided by our number of observations. And so this question I kind of don't like because in the data part, it gives you the data for the males and then the data for the females, but then it asks you to have the females first and the males second. So you have to be careful not to mix those up. So we're just going to divide the yeses by the total. And so we'll do the females first because it says females and males. And so females will be first. So we got 208 said yes out of 562 females that we asked. So that's our first proportion. And then we're going to look at the males. And 189 said yes out of 589 that we asked. And so now we're going to do the qualifications that we've been doing this whole time. So it asks if the samples are dependent, and I'll skip to the bottom where it says independent. So we got to decide if it's dependent or independent. And basically what we're looking at is that what a male says to this question has no effect of what a female says. We're just seeing if there's a difference at all, but it's not like we're asking the same people 5 years later or something like that. That would be a dependent sample, but it's going to be independent. And another clue for that is we are talking about proportion stats. And if you notice in proportion stats in StatCrunch, there's only one sample, two sample. There's not a paired. Whereas in T-Stats, there's a paired. And when we're using the paired in T-Stats, that is when it's a dependent sample about the mean. And so if we're talking about a proportion, it's going to be independent. Okay. And then sample size has to be less than 5%. That's still true. This equation is still true. Not more than 5%. And since we're working with such big numbers, the data does not have to come from a population that's normally distributed. So we will not highlight that. Okay, now we're identifying our hypotheses, hypothesi, I don't know how to say that plural, but so our null is we're saying that there's no difference between what the females and males say, and it says, does the evidence suggest a higher proportion of females are annoyed in this behavior? And P1 represents the females, P2 represents the males, and so we're saying P1, a greater number of females represented by P1 said that they were annoyed than males. Okay, now this gets a little tricky because what we want to do is we want to take our proportions that we found up here and plug them into this little equation that they give us, but that's not what we do. Do not do that. We're talking about a normal model and it's representing the p-value. And so when the mean is going to be 0. And that's just how it is, and I don't know if I can really explain it any better than that. Okay, and then for the standard deviation, we can go into stats, proportion stats, 2 samples with summary, because that's what we have. We have a proportion, 2 of them, and we're given the summary. And so we can't be careful not to mix up your females and males. So females are first. And then change this right now, even though it wouldn't really matter. in a minute, but yeah, make sure that it looks the same. This sample difference right here, the standard error is you can plug in for your standard deviation. Okay, now I'm going to make it bigger because it's hard to see these graphs. And so we're drawing what we just made up here. So it's going to be 0 in the middle, and we're looking for the blue part in this graphs is when we're going to reject the null hypothesis and say, yes, there's enough evidence to conclude that females are more annoyed by this than males. And so it's going to be very much above the 0, like this right here. Okay, now we're doing the test statistic and p-value, and we already found that right here. And so that's why you got to make sure that you did this sign right, because if you've just left it at the equal sign with the slash through it, the not equal to, your standard error would be right, but your p-value would be wrong. These two would both be right, but the p-value is wrong. So make sure it says the greater than. Test statistic is your t-stat, and p-value is the p-value. Now this one gets a little tricky sometimes, but it's asking if they're equal. So if our null hypothesis is right, and the reason why we're talking about that is because our p-value, you know what, never mind. They're just equal to. And one would expect a sample difference proportion greater than the one observed in about, and then you times that by 1,000, which would be 40 out of 1,000. So now we're going to compare our p-values. So p-value is 0.040, and our alpha is 0.01, and this is greater than, so we're not going to reject our null hypothesis because there's not sufficient evidence. If we're not rejecting, then there's not sufficient evidence. And there we go. That's question 17.